You don't have to rewrite that, but to kind of go back to basics here with cell division, why do we do it? Why do we do cell division? What's it for?
Supply cells that have been killed off.
So to replace cells you already have, like it. But like at a basic level, you're an organism that's going to be multicellular. You start doing mitosis to grow, right? Why are there so many? Do you know how many cells you have? That's good. Somebody said tens of trillions. That's the right order of magnitude. About 100 trillion, give or take a few 100 million. How come it's not 100 million? Just bigger. See what I'm saying? Okay, if I took a tissue sample of you, and then I took a tissue sample of an elephant, and then I took a tissue sample of a flatworm, the elephant would have really big cells, and you would have medium-sized cells, and the flatworm would have small cells? No. Weirdly enough, y'all have about the same size cells. Cells are mostly pretty similar sizes. I mean, bacterial cells, right? Prokaryotic cells are a good deal smaller. Eukaryotic cells are bigger. They don't really get much bigger than about 1 millimeter in diameter. I mean, a couple exceptions, but nothing real big. 1 millimeter, like an amoeba, a little one-celled thing that swallows stuff up, right? Or a human egg cell. Those are maybe 1 millimeter in diameter. Like, pretty much not in the history of the 3.7 billion years of evolution has it gotten much bigger than that. There's got to be a reason for that. When something is that consistent, there's a reason. There's a reason that size rule doesn't get broken. Any ideas? Because that's the big question today. Why are cells so dang small? There is some stuff about DNA that goes along with it. It's not what we're going to focus on, but yeah, it would take a little more DNA than we've got. Not the important part, though.
Like efficiency?
Yeah, it definitely has to do with efficiency.
Is it about the surface area grows less than the volume?
It has to do with geometry, absolutely. We're going to start using words today like surface area and volume. And we're going to use some formulas that you thought you had left back in geometry. We're going to repurpose them for cells. That's what we're going to do.
But with volume, bigger area because it's heat instead of square.
Yeah, so the start of this is that basically as stuff gets bigger, stuff that is three-dimensional, the starting math of this, some of you already know, that volume increases faster than surface area does because of the concepts of cubing and squaring something. We will get a better hold of those things. If you don't understand them yet, that's fine, okay? We're about to experiment a little bit with sizes of three-dimensional objects. Cells are a mess. Cells are all blobby and stuff, right? We don't want to measure surface area and volume of actual cells. So we're going to measure surface area and volume of the easiest 3D shapes you could possibly work with, which are cubes. Cubes are great. So you're going to make some cubes. You're going to make some cubes. Might as well build a little snowman out of them because you're making 3 different sizes. So that's what we're doing. And then you can do some math. You just cube. You're just going to make some paper cubes. And the way you're going to make paper cubes is you're going to need a ruler and the idea of this shape. right? When you draw this shape, you draw a shape that you can easily cut out and make into a cube. Yours will be much better than mine because it'll be precisely measured, but the basic idea is you're making 6 squares. And when you cut that out around the outside of it, you will be able to fold it up and tape it into a cube. You're going to do, with your partner, 3 cubes, where this length right here, which is of course the same for all these lines, is 2, 4, and 6 centimeters. So make sure you're using the metric part of the ruler. 1 cube that's 2 by 2 by 2, 1 that's 4 by 4 by 4, 1 that is 6 by 6 by 6. I would call that kind of the kindergarten part of the assignment. Okay, I just want something concrete in front of you so that you're thinking about cubes. You can put as much or as little effort as you want to into your little snowman made out of 3 different size cubes. I'm really more interested in the math. However, I'm also interested in a snow day. I really want a snow day. When they told us that we get 3 snow days, like they're not going to make us do remote learning for the first 3 days where we get bad weather, I was like, yes. So the better you make your snowman, I feel like the better chance we have. I'll also tell you about other ways as bad weather gets maybe closer. I'm looking at next Thursday. We'll see. There's a couple of things you can do to improve your snow dance, and you know, there's some science we can use on this. But first and foremost, cool snowmen. So this is a contest. It's separate from the grade for this. The math is the important thing. Answering the questions correctly is the important thing. That's what I want you to spend most of today's period on. But like by next Wednesday, if you got a super cool snowman, there's going to be a contest. And I'm going to pick my favorites for each class. And my favorites might get just a little bit extra credit. Okay? So that's for Wednesday. You got some time. I want some cool things laying around. CP did okay with this. I think you can do better. Okay? For the questions, there's formulas. I think you probably know these formulas already, but let's just make sure. Do you know what surface area is? Like if you talked about the surface area of me, what are you talking about? Skin, good. Skin is my surface area. And if I was a cube, how would we measure how much skin I had?
Take the area of 6 sides and then multiply it by 6. Just take the area of one side and multiply.
Area of one side times 6. And how do we find the area of one side of a cube? Length times width, except we don't even have to say that because length and width are the same. So it is S. So really the formula for the surface area of a cube is 6S squared. How about volume of a cube? By the way, if it was me, what would we be talking about if we were talking about my volume? Let's call it guts. Yeah, the stuff inside me. Okay, fine. If I was a cube, how would we measure my volume? Length times width times weight. Are they all the same? So what is it? Some of you have never really thought about this enough. If you're like me, when I was probably embarrassingly like much more recent than you, but I never thought about the fact that the reason we use the terms squared for to the second power and cubed for to the third power are exactly this. Whoa. I know, you were today years old when you learned that. So what we're really interested in, if we're talking about 3-dimensional objects and cells and surface area and volume, is the ratio. So what you'll end up with is a surface area to volume ratio. And what I'd like you to do to equalize those numbers for each of the 3 cubes is to divide them out so that it's something to 1.